Learning target 474 says I can graph a function modeling a real-world situation and use the function to answer questions and interpret answers about the situation. Basically, this is kind of a review of learning target 473. Can I graph a function? So the gray wolf population in Minnesota was monitored for a project aimed at boosting the number of wolves. The number of wolves can be modeled by the function p of x equals 20x plus 10, where x is the number of years since 1998. So that means year 0, the start of the study, that's like 1998. Year 3, for example, would be 3 years later, that'd be the year 2001. Now, one thing, remember, the function form is just fancy notation. Instead of saying p of x, think of it as y equals 20x plus 10. You want to recognize that this is in slope-intercept form, where your y-intercept, the number by itself, is 10. Your slope, your m value, is 20. If you want to think of it as a fraction, maybe 20 over 1. Now, anytime you're making a graph of a real-world situation, you have to have labels. So x is number of years since 1998. And on our y value, or our p of x, if you want to think of it that way, that's going to be the number of wolves we have. Sometimes it's nice to have a title to your graph as well. Maybe I'll call this Minnesota Gray Wolves. Okay, first thing we have to identify is our y-intercept is 10, and our slope is 20. So we're kind of thinking it's going to start at 10, it's going to go up by 20 every year. 10, 30, 50, 70. We want to choose an appropriate scale. If you go by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, you're not even going to fit your y-intercept. So make your life easy. Maybe we'll select the y, the number of wolves, to go up by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. One thing I noticed a lot of people did on their test is they maybe started at 20 here, and then they went 30, 40, kind of like that. But this box then isn't equivalent to the scale on this box and this box. Here I've gone by 10 by 10. Here this box means 20. We have to stay consistent. You can skip a bunch of values too using the heartbeat, but in this case, since our first value is 10, that's not too far away from 0. I'm just going to start it right there. Since I'm going by ones, I don't have to label here, but maybe I'll just do it for fun. So 4 years since 1998, that would be like 2002. All right, here we go. So my y-intercept is 10. My slope is 20. So I'm going to go up 20 over a year. Up 20 over a year. Another year, another 20 wolves. If I graph it, I should probably use array, simply because I'm not going to have negative wolves or negative years. There's part A. Part B, estimate the expected gray wolf population in 2013. A couple ways you can do that. What I'd probably suggest is, remember, this is years, X is years since 1998. Well, how many years since 1998 is 2013? It's 15 years. Okay, so take your equation. Y equals 20 times 15 years later plus 10. So you've got 300 new wolves plus the 10 original wolves. You're looking at 310 wolves in 2013. And then 12C, it says estimate the year when the gray wolf population will be 70 wolves. You could look at your graph and see, hey, 70 wolves, that's right here, and that's year number 3, which would be 3 years after 1998, 2001. Or from an algebraic standpoint, you could say, well, here's my equation. 20 times what plus 10 is going to give me 70 wolves. Subtract 10, divide by 20, and you're looking at, again, 3 years later, so 2001.